Hi everyone, welcome back to our YouTube channel, Becoming a ROS Developer. I'm Rodrigo, and today we have another one of our students. His name is Ernest, who has completed the ROS2 Basics in 5 days course. And at the end of this course, students can complete a project. This is a real robot project, and then present it to get a certificate from us of learning. So this is what we're going to see today. We're going to see our student present his project on what he's learned for the course ROS2 Basics in 5 days. So hello, Ernest. How are you?
Good, thank you.
Okay, I'm good too. So yes, whenever you want, you can start sharing your screen, and we can take a look at what you've done with your project.
Okay, sure. Yep, can you see the screen?
Yes, I can see the robot and a terminal.
Okay, so I will run the code. So right now it's turning to face the closest wall.
Okay.
So it's moving towards that wall and then turning so that its right shoulder is next to that wall.
Mm.
And then now it's following the wall all the way around.
Okay. What is that output we're seeing on the terminal?
So you've got quite a number of things. You've got
Uh-huh.
the feedback of the total distance that it's traveled from the start, and also the absolute distance to the start. So basically, it's displacement.
Okay.
And you've got some log messages of what it's currently
What
doing.
it's
So
doing.
right now, it's in wall following mode, and it's saying sharp left or adjust right or adjust left. So sharp left is when it encounters a corner, it veers sharply to the left, so it
Uh-huh.
rotates on the spot. And slight right or slight left is just small adjustments as it moves forward, following the wall.
Okay. And then eventually, will the robot stop, or what will happen?
Yes, so when it reaches where it started, it will terminate and stop. So almost there. So within 5 centimeters.
Nice.
So sometimes I do have to set it so that it's 10 centimeters. So you might have seen that it was within 7 centimeters, but it never quite got to 5 centimeters.
Right.
Um, so it would have to go all the way around again sometimes to be able
To
to hit
catch
that.
that
And yeah.
tolerance. Okay. Well, we can. I mean, it doesn't matter. It can keep going as long as we want. So, do you mind just sort of explaining, now that we've seen the behavior?
Mhm.
Do you mind explaining how you've identified which the parts that you worked on, and how you solved them?
Yes, I can do that. So can you see this image here?
Yes, I can.
So I've made a flow chart
Nice.
of the three nodes that are used.
Uh huh.
So you'd first of all launch these two servers, and then you launch this client, service and action client. Um, so you'd first start off by requesting on the client side. So for the service, to the wall finder service. So you would ideally, in this case, check whether the laser on the right is equal to the shortest laser, which means that your right shoulder is facing the wall.
Uh-huh.
Um, so that's the first thing you check. But if it's not, then you basically have three loops here, and these are three while loops. So the first thing you do is you check if the laser forward is greater than the shortest laser. That means that it's not currently facing the wall, and so it has to first of all rotate anti-clockwise continuously until it rotates to face the wall, and then eventually that's not true, so then it moves forward to
Mm.
go closer to that wall, um, and it keeps doing that until that's not true, and then it rotates again until in this case, the right shoulder is facing the wall, so that it's ready to, when that's not true, start following the wall. That's when the wall has been found.
Mm-hmm.
Then it responds to the client and begins this wall following procedure. This is a timer callback, so every 0.5 seconds. In this case, this was a series of while loops with 0.5 period,
Mm-hmm.
but here it's a timer callback. In this case, you would check first if the forward laser is less than 0.5. Yes, that means it's time to make a sharp left. So you rotate anti-clockwise on the spot. And once that's not true, if that's not true, then you check the laser on the right. If that's more than 0.3, then you would move forward slightly to the right to go closer to the wall.
Mm.
Um, if it's not true, then you check the laser. If the laser right is less than 0.2, then that means you need to do the opposite. Otherwise, you just keep going forward.
Mm.
And um, notice how this splits off into two, because this also, when the follow wall is true, it also sends a goal request. And it basically asks the inside the server, is the total distance less than or equal to 0.05, so 5 centimeters? Or is the distance to the start greater than 5 centimeters? And basically what I'm trying to do is that I want it to keep I want it to keep recording the odometry
Yeah.
until it goes back to where it started, but only after
It's on a full lap.
it's done a full lap. That means that its total distance is more than 0.05 and the distance to start is less than 0.05.
I see.
That's when it's not true. Um, and then you stop recording the odometry. And the feedback is happening constantly, giving the total distance. Yeah, that's
Oh,
pretty much it.
all right. Can you clarify the absolute versus relative distance that you mentioned? So one of them is the absolute and one is the relative. Can you, with respect to what, or what's the difference between those?
Yes, so the absolute distance is basically just the straight line distance to the start, and basically the total distance is a sum distance of basically at every second you are measuring the straight line distance to the previous way, like basically point,
Uh-huh.
um, and you're just summing up all those straight line distances as you zigzag along, and that gives your total sum distance as you go around the track.
Okay, and so they differ, but you needed these two to be able to detect when you come back to the same spot.
Yes.
Okay, okay, okay.
In this case, my implementation.
All right. Okay, cool.
Um, yeah.
So did the robot finally hit the spot, or is it still trying
Yes.
to go around? Oh, look.
Yes.
Yes. And
So
then,
obviously the odometry would have been a little bit warped now that it's gone around a few laps.
of course, yeah.
But it's close enough.
Yes, yes, yes. And what
Yeah.
is that output we are seeing?
So this output is basically all the points at every second um, it recorded as it followed the path.
Okay, and who's in charge of spitting this out, basically?
Um, so the basically the odom recorder is in charge of recording this out, and then here you respond with the odom record. So you're updating the odom record. It's basically a list, Python list.
Uh huh.
You're adding these XY points as you go along,
I
and
see.
each XY point is goes in that list, and then you publish the whole list of XY points
And
and you
that
print it out.
gets printed out when the robot finds that uh, spot, right? The initial spot. Otherwise, it will just continue. So this is basically like two laps.
Yes,
Is my question. So if we were to
yes,
see it plotted, we would see like two roundabouts.
yes, that's
Okay.
right.
Okay. Nice. Well, do you have any other comments that you want to make specifically on the project?
Um, yeah, I guess like some interesting. I so multi-threading was obviously needed to concurrently run callbacks in the same like node.
And which
For
callbacks were that?
um, so you had for wall finder, you had the service callback and
Yeah.
the laser callback.
Right. Okay.
So you have sensors receiving at the same time as you have a service which has a service callback which has a while loop inside.
Yeah. So it might never.
Yeah, it's running for a non-trivial amount of time, so you do need multi-threading.
Yes. And the same for the autumn record. Is that the same scenario?
Yes, that's right.
Okay. And
Um,
actually, the main node as well. No, because you have the
uh,
lighter.
I
Oh,
didn't actually need it. Yeah, it was fine without it.
okay, okay. Because you only have the laser in that scenario. You don't have a service or action called service or an action that might add one there. Okay,
Yeah.
great. Well, that's amazing. Well, if you don't have anything else to mention, I want to say congratulations. Really, really clear. And I want to mention that this is a perfect way of presenting it. I
Thank
believe
you.
with this flow chart, this is uh, usually, you know, people think about slides or
Mhm.
showing, which I'm not saying is wrong, or
Yeah.
showing the code line by line. But the easiest for us, the spectators, is something like this that is graphical, that presents very clearly. We can see the three components and how to communicate between each other. So thank you, at least, I guess, for doing it this way. It's very, very clear for me, and it shows a good understanding of the project, which is the main goal. And other than that, those are the comments I have for you. I'm glad that you did this so well, and again, congratulations. And do you mind
You.
stopping sharing your screen? so we can say goodbye here.
Sorry,
Do
what
you
was
mind
that?
stopping sharing your screen, please?
Oh, yes, sure.
So we look at you instead of the which is nice, a nice flow chart. But yes, congratulations, very clear, very straightforward. Uh, Looks like you had some experience with coding in Python before this. So is that correct?
Yes, that's right.
Yeah, okay. So we can see a little bit of that, and I hopefully by taking this course, you can see how to integrate that with ROS2 now. So again, congratulations, Ernest.
Thank you. I enjoyed it. It was very fun.
Oh, I'm glad to hear that. And to everyone else watching, you can do what Ernest did here after you complete some of our courses that offer a certificate of learning. We take those very seriously, and that's why we ask for this presentation so we can personally attest that someone has done this work and taking something out of our courses. So I invite everyone that is watching to try what Ernest did here and do a real robot project for one of our courses um, in order to showcase what you've learned. So yes, for everyone, everything else we're covered. So I guess this is it from us, Ernest. Thank you very much again, and hopefully we will see you around.
Thank
All
you.
right. That is it from us at Becoming a ROS Developer. And remember to always keep your push your ROS learning. Okay, everyone. Bye bye. Okay, we're done.